Today I will be showing you the difference between synchronous and asynchronous communication in a system. We will also be building a system using Kafka to go a bit more in detail about asynchronous systems, so stay tuned. Also, don't forget to like and subscribe as it helps me to make better videos for you. Let's start by looking at this diagram. So this diagram shows a synchronous system. So this is tightly coupled. So what does tightly coupled mean? Tightly coupled means that order service relies on inventory service. So if inventory service is slow in responding to the request sent by order service is going to be blocked as well. We usually prefer using synchronous system when we need an immediate response. For example, you can use a synchronous communication system when you have quick responses from the system that is serving requests. So let's look at this example a bit more closely. We've got a client that sends an order request to this order service. Order service then sends a request to inventory service. So we can imagine that when we get an order, we want to update the inventory, but order service is going to wait until inventory service has updated the database in this example. And then once the database is updated, this is going to be sending a message back to order service with the outcome of this operation. And then order service can go back to the client and give back a response. But if there are issues in inventory service or the DB service, or if these two systems are slow, order service will be waiting, and we don't want to wait and consume resources for no reason. In this case, we've got another type of communication, which is asynchronous. Asynchronous communication allows us to build loosely coupled system. This is also called an event-driven system. I will be showing you an actual example using code on how to use Kafka to build an asynchronous communication system between two services. And this offers better scalability and resilience. Let's look at this example. So we've got a client that sends a request to order service. Order service puts a message on a Kafka topic. In this case, Kafka is going to be returning a 200 straight away once the message is on the topic. And then notification service is going to subscribe to this topic inside Kafka and consume messages at its own time. So let's say order service gets a spike of orders. It's going to be sending these requests on Kafka, which is quite good at handling big volumes of data. It will get these messages, and notification service can then go and pick up these messages one by one and process them. And this is an asynchronous communication system. Let's add another diagram to the asynchronous communication. So in this diagram, we don't know once notification service has saved the data and what was the outcome. And we have two options now. So the first option is to poll notification service to see if the operation we sent on the Kafka topic was actually executed and what the outcome was. But again, this is not really efficient, right? You're just going to be polling. The other option, which I think is way more efficient, is to have another Kafka topic. This time it's going to be notification service who's going to publish on this Kafka topic the outcome of the request that it received from order service. And then order service is going to be consuming this topic to get the outcome of this operation that it sent earlier. In this case, because this is a notification service, maybe order service wants to know if the notification has been sent, and then it can update its internal tables where we are handling order emails or whatever. So this is just an example I wanted to show you. So I am not going to cover a typical synchronous call between two services because it's the base scenario, which is quite common in developing, where whenever you make a request, for example, using a REST template, that's a blocking operation. The REST template is actually waiting for a response. And that is what this diagram is showing, which is showing a blocking operation. I am going to show you the implementation of this Kafka topic where two services, order service and notification service, are exchanging messages asynchronously. If you want to follow along, please install what you see on screen. These are the technologies you need installed on your machine to be able to follow along. Please don't forget to like and subscribe to the video, as it allows me to create better content for you. Let's now jump into the implementation of this asynchronous system. For those of you who don't know what Apache Kafka is, let me give you a brief introduction. So Apache Kafka is an open source distributed event streaming platform that is used a lot in the industry. What it allows us to do is to have two systems communicate asynchronously by exchanging messages. So we will be having a topic, and this topic is going to be accepting messages from a producer. And these messages are going to be consumed by a consumer, which is going to subscribe to this topic where the messages are getting published. It is quite powerful because it's high throughput, scalable, and it also offers high availability. So it's quite good at handling big volumes of data. And the best thing is that it's also open source. We can also say that it's the industry standard. I will show you how to run a Kafka message broker on your own machine using Docker. So stay tuned. What we need to do now is create two Spring Boot services, one for order service and one for notification service. So just go on Spring Initializer, create a Java Maven project. We will be using Spring Boot 3.4.5 and give your project a name. So I'll create notification service, leave it as a jar, Java 21, and then we need these three dependencies. So Spring for Apache Kafka, Spring Web, and Lombok, and we're good to go. So click generate and download this. And the next thing we also need is another project for order service. We need two so that we can simulate the messages going from the consumer, which is going to be order service in this case, to our consumer, which is going to be notification service. So let's click generate and let's open this project in IntelliJ. So we are going to start by working on order service. This is going to be the producer service in this case. So we're not going to be building a full-fledged system, but we'll keep it simple. So let's start by actually running Kafka on our local machine. And to do that, we're going to be using a Docker. So let's create a Docker Compose file. So this needs to be called Docker Compose. .yaml, and here we're going to define the services we need to run a Kafka messaging system on our local machine. I have already written this. I'm going to paste it. Let's go through this to show the services we need. So the first thing we need is Zookeeper. Zookeeper is a system used to manage the Kafka brokers. So it's kind of a layer above Kafka messaging system that is used to manage the Kafka brokers. Then we've got the actual brokers. This is where the actual messages go. We have defined some ports. We will need these later. We have this property to connect it to Zookeeper. And as I said, Zookeeper is used to manage Kafka brokers. I have also added a Kafka UI. Kafka UI will allow us to see what's actually going on. It will give us a visual representation of what's going on. So this will be running on port 8084. And as you can see, it will hook into the Kafka brokers. The last thing we need is Kafka schema registry. And this is where all the JSON schemas, for example, are stored. Once we have the Docker Compose file, we can actually spin this up. You can do Docker Compose up, and because I've already run this before, it's going to be a bit quicker. Just make sure you've got Docker running in the background or you're going to get an error. To verify if this has been successful, let's go on the web browser and let's go to localhost 8084. This is what you will see. Let's now create a new Kafka cluster. So I will call it localhost. We need to give a host name, so I will call it Kafka Broker, and the port is going to be what we have defined in the Docker Compose file. So if you don't remember, just go back to Docker Compose, and as you can see, this is going to be running on port 29092. So let's go back here. We can validate. The validation was successful, and let's click on submit. And as you can see, a dashboard has been created. If you refresh the page, you will see the brokers. As you can see, we have some default topics, but this will be created by our Spring Boot application. For now, let's leave this running on one side. And let's go back to our order service. So we are going to create a new package called service. As I said, we're not going to create a full system with a controller and etc. We will just create the service class, and then we will create an event. Let's create a new class in here called order service. And in here, we're going to tag this as a service class. Let's also add some logging. Let's also add all args constructor so that any kind of private variable will be automatically injected into the constructor. So the next thing we are going to do is actually create a method to put a message on our Kafka topic. If we go back to our diagram, this is what we're going to be doing. We're going to be generating a string on order service. And this string is going to be an order ID, which we will put on a Kafka topic. And then we will simulate notification service reading this message from the Kafka topic. Once we have done the string, I will also show you how to exchange more complex messages. For example, a JSON object. We will cover these two scenarios, but we will first start by exchanging a simple string between these two services, which is going to be an order ID. So let's go back here. Let's call it public void process order. So in here, we're going to generate a random order ID. And we will be using a UUID. Let's generate a random UUID and convert it to string. Let's make this final because we're not going to change it. Let's log it. So log.info processing order, and then we'll print the ID. Now we're going to send this order ID on a Kafka topic. So how are we going to do that? We are going to create a Kafka template, and the Kafka template looks like this. This second attribute is the type of object that we're trying to publish on the topic. In this case, it's a string as well. Then we can simply use the Kafka template, do send, and let's give the name of our topic. So we will call it order placed. And we're going to send the order ID. Because we don't have a controller to trigger this, I'm going to use scheduled to schedule this to run every 10 seconds. Actually, let's make it every 2 seconds. Now we've got the method to generate the order ID and publish it on the topic. We are only missing some configuration. So let's go to application.properties. Let's add a bunch of Kafka configuration. We need to define where the Kafka broker is actually running. So it's going to be running on port 9092. Let's define the topic. As I said, it's going to be called order placed. You don't really need to define this because we already have it in the Kafka template. When we do send, we actually decide the topic where this needs to be sent. This just defines the default topic. If you were to not provide any topic in the template, in the Kafka template, this is the default topic where the message will be sent. We need a key serializer, which is going to be a string serializer, and we need a value serializer. So in this case, we're going to be using JSON. This is all we need in order service to publish a message on the topic. Let's run this and let's see if the messages actually get published. So let's create a configuration, call it order service, and let's run the application. Click apply. Okay. Before running this, we forgot one thing. So we need to add on the actual order service application class the enable scheduling tag. Because we've got this schedule tag, we need to define this enable scheduling to be able to use this. Another thing, when you want to schedule something, you have to make sure that there are no method attributes in here. Otherwise, this is not going to work. And also, let's add some logging here. So let's print message sent to Kafka topic with order ID. So if we now run this, hopefully this has no errors. As you can see, the messages are getting generated with UIDs. So every 2 seconds a message is getting generated. Let's go to our Kafka UI. Let's refresh. And as you can see, a new topic has been generated. If you go inside, let's go to messages. Here are all the messages that are getting generated. And if you click on it, you can actually see what is getting sent on this Kafka topic, and that will be consumed by the consumers. So we've got the order service ready. Let's now work on the notification service, which is going to be the consumer. I have opened notification service. Now we need to consume the messages that we're placing on the topic. Let's create another service class. This time in notification service, let's create a service package. And let's create a notification service class. So I'll call it notification service. Let's add the service tag, and let's also add logging. In here we need to create the Kafka listener, so we need to listen to the messages that are being placed on a specific topic. And to do that, we're going to be using the tag Kafka listener. We are going to define in the topics the name of the topic we want to listen, and this is called order placed. And we want to define a group ID. This is going to be called notification service. A group ID is a unique string identifier used to group multiple Kafka consumers into a consumer group. It basically tells Kafka that all these consumers are part of the same team working together to consume messages from a topic. Next, let's define the method to consume these messages. Let's call it get order number, and this is going to be a string. As we said, we are going to accept strings. Let's log the order ID we got, and then you're free to do any work you need to do with this order ID. You can save it in a database, or you can do all the other operations you want. This is just a simulation. This is all the code we need to consume messages from a topic. The only thing we are missing are properties. Let's go to application.properties. We need to define a port in this case because order service is already running on port 8080, and to avoid conflict, let's define this to run on port 8081. And we need a bunch of Kafka configurations. These are similar to before. We need to define these properties, so we need to define where the server is running, where the group ID, as we said, notification service, a deserializer. So because the serializer was a string, the deserializer is going to be a string deserializer. And same for the value deserializer. Again, we are going to be using a JSON deserializer because we use that JSON serializer in the producer. We don't need this for now. Ignore this. This is for the next step. We don't need it for now. We are now ready to run this and consume messages. Let's create a new configuration. I'll call it inventory service. Apply, okay. Let's run this. As you can see, this has already started consuming messages from the topic. Here you go. We have the consumer group notification service, and this consumer group is consuming topic order placed. We might be able to search, so I got this from the logs in inventory service, and yes, as you can see, this has been consumed. We have seen how to consume a simple string, but what if you want to publish more complicated objects on these topics? Let me show you how to do that. Let's stop this for now, and let's go back to order service. Order service, as we said, is our consumer. In here, we are just sending a normal string order ID. But what if you want to send a whole order object? So let's start by creating this new order object that we will be publishing on the message topic. In this case, when you get an order confirmation email, you don't just get an order number most of the times. You get the details of your order. So for example, you get the price you paid, the products you have ordered, the quantity, and etc. So let's create a really simple order object that we will be used to send notifications. One thing to keep in mind is that this object needs to be shared between order service and notification service. So we will be creating a new package, and this package will be under com.LeetJourney, and I will call it event. And in this event package, you would be putting more complex objects that you want to publish on Kafka topics. So I'll call this order notification. Let's add a bunch of tags. Let's add constructors. Let's add a builder. Let's also add an OArgs constructor. And let's add a bunch of properties that our order could have. So an order ID, user ID, product, quantity, price, and order status. Let's go back to order service. And in here, let me also show you how to use multiple Kafka templates. So instead of modifying this, we'll just be adding a new Kafka template that we will be using to send this new object. A new Kafka template. This is going to stay string, but the second part is going to be a order notification object. And once we place the order ID on this topic, we want to place the order notification object on a different Kafka topic. Let's create a new private method for that. So process order notification. We'll pass the order ID, we'll just reuse that. And yeah, let's use Copilot. So we'll get this order ID, we'll create our order notification object. I've been putting some random values. We're missing the user ID. Let's give it a name. We will be using the second template we have created, Kafka template order email. And we will be putting this on a different topic. In this case, I decided to call it order placed email. And we will publish this order notification and we'll print the message. So every 2 seconds, we'll be putting an order ID on the order placed topic and an order notification on order placed email. So I will run this. We will start producing order IDs and we will also be putting order notifications. Let's see if it's also placing emails. As you can see, it's also publishing messages on ordered placed email. If we go to the Kafka UI and we go to topics, we can see a new topic has been created, which is called ordered placed email. If you click in here and we go to messages, we can see the messages that are being published on this topic. This is exactly the structure we have defined in our order notification object, and this is what is being sent here. Now we need to consume these messages. So let's go to notification service and let's handle these other messages. So because they're coming on a different topic, let's create a separate Kafka listener. So the topic name has changed this time. As you can see, we need to define this order notification object inside notification service. We need the same path as we had in order service. Under com.LeetJourney, I will create again an event package. In the event package, we're going to create an order notification class. And we're going to have the same attributes as the one in order service, so we can just copy and paste. Let's go back to our service class. Let's import. And here we're going to be printing the whole order we are getting from the Kafka topic. You can simulate sending an email. I will simply just print the whole order notification object. So we need to tell Kafka that this package is a trusted package and to use this class to deserialize the message. In your application.properties in notification service, you need to add this line, and you need to define the package where this order notification class is. So let's try to run inventory service again, and hopefully this time it should work. We have a new log line, notification sent. So this is getting the whole order object and it's actually printing it. So we got user ID, product name, quantity, price, and order status. And using Kafka topics, we have exchanged messages between two services. We have notification service that is consuming two topics inside Kafka, and these topics are being populated by messages from order service. So we have built a loosely coupled system. Order service and notification service can scale independently from each other. If one is down, for example, if notification service is down or it's being slow, order service is not going to get affected by it. And this is a desirable property we want in enterprise software or reliable software. We have built an asynchronous system in this video, and I've shown you how to use Kafka to create a loosely coupled system that is event-driven, where we're using Kafka to exchange messages. And if you've ever wondered how I keep my coding skills sharp all year round, then let me introduce you to Brilliant. Brilliant helps you get smarter every day with thousands of interactive lessons in math, science, programming, data analysis, and AI. It's hands-on learning that actually sticks. Instead of passively watching videos, you're solving fun, bite-sized problems that train you to think like a real programmer. Whether you are learning a foundation or brushing up on advanced concepts, Brilliant makes it easy to learn anywhere, anytime with their mobile application. To try everything Brilliant has to offer for free for 30 days, visit brilliant.org/LeetJourney or scan the QR code on screen. You will also get 20% off an annual premium subscription. Huge thanks to Brilliant for sponsoring this video.